Yes, we thought it might be fun. We've had a lot of interest in microservices. We were in the big room for the big reason. Lots of people have been coming along. And we have a bunch of people from different backgrounds who have different viewpoints on microservices. Some people here do not agree with me. That's Fred. And so that's why, I like having this. It's good to have a bit of conflict of interest. It'd be nice. So we're going to get some questions coming in from the audience. You should be able to go and ask questions on the app, although we've had a couple of little niggles with the app for the last couple of sessions, but I'm going to kick things off in a minute. But before we get going with the questions from the audience, I thought I'd maybe ask people to briefly introduce themselves and sort of what their exposure to microservices has been. So maybe we'll start with you, Fred.
Yeah, thank you.
Are these on? Hello? Yes. Speak very close.
So, my name is Fred George. I've been playing with microservices off and on for about 10 years. I've made a lot of mistakes in the process, and so I'm very, very prejudiced of how I do them now.
I'm Rod Johnson. I guess I partly got into microservices through Spring. Not because microservices and Spring are synonymous, because obviously microservices are much more than any specific language or any specific framework, but because really microservices is actually the architecture that Spring always wanted to be. Like back in the early days of Spring, I always felt that the big, fat, monolithic application server was not the way to go, that the way to go was small pieces of functionality that were coupled through well-defined contracts, and microservices totally fit with that vision, and I'm very excited to be trying to play a role in that future.
Good morning. I'm Jessica Kerr. I've been a developer for 15 years, and I've been fascinated by microservices since I heard Fred talk about them 4 years ago at ORDEV. And at the time, I was like, lots of languages, itty-bitty little things that we can throw away. And over time, I'm not so keen on the lots of languages or the super small size or the throwing them away, but I am still really keen on microservices because they represent a form of system evolution. And I'm fascinated by the evolution of the complex systems that are our software today.
Hi, I'm Mike Nygard, developer, architect, operations, and author. My particular focus is on building software that survives production and the real world. I spend my day job doing two different things: developing really small, loosely coupled parts in Clojure and consulting to very large companies that wish they could move faster. So I have this sort of whiplash when I go from one gig to another gig. So I'm constantly looking at ways of evolving things faster and dealing with complex systems, but I'm also always wary of the production overhead and burden and performance implications and stability implications and so on. So I look at things with a jaundiced eye.
And if I can just butt in here, if you haven't read Michael's book, you really should.
Thanks.
Do you get a cut on sales for the... No, anyway, we should
I am now obliged to agree with everything Rod says.
So maybe just to start a question from me, and we'll start taking them from the audience. Why is there an interest in microservices now? What's been different over the last couple of years? Why is it the buzzword du jour?
I think, first of all, we had a big architectural enabler through the fact we're using virtual machines and now containers. And so it's now easy to build and package very small pieces of code and deploy it, versus allocating an entire machine for a process. I think that's been the key enabler that I've seen.
Yeah, I'll add on to that the other enabler was sort of motivated by virtualization, which was all the automated operations tools, and particularly automated operations that was open source. So you didn't have to commit $2 million to implement HP OpenView for your company.
Yeah, I think there's also been a broader move towards using larger number of smaller boxes. That's been going on for a very long time. But I think that microservices and containers really make that a very feasible thing. And I think actually one of the major drivers is doing it the old way is becoming increasingly problematic. We've got more client types. We need to deliver business functionality faster. Although there are challenges in adopting microservices, I think we'd learnt that the old monolithic way was kind of getting toward the end of the road.
I agree. Our systems are getting so big now that we just have to break them up, or they grind completely to a halt and we can't change them because change is too risky. So we've had to find a way to be able to make changes at a smaller scale, to decouple the work of one team from the 18 other teams in the department.
So we've had a question in. Thank you, audience. I like these things coming in, but it's a bit impersonal. So Jessica alluded to the size of microservices. Some authors have suggested microservices should be replaceable in a single sprint. Is there a right size for a microservice? Now, I might start with Fred on this one, because I know, Fred, you have views.
One of the things that we sort of settled on in Berlin at some of the microservice conferences is we kind of all agree that if it's more than one programmer to develop and design and maintain it, it's not a microservice. Mine tend to be smaller. I tend to have 30 or 40 microservices for a team of 5 or 6 people. So generally, they're quite small in my world. But if it's more than one programmer can sort of get their head around, you're probably not in the micro world.
I think you get a whole team. And a team could be ideally like fewer than 6. And then but that's just to be an independent service. And to me, a microservice is, I don't care about the size. What I care about it represents like one business concept and capability, and that it keeps its data to itself.
Yeah, I tend to agree with Jessica. I think that one of the major drivers is the data. And, so to whatever size is appropriate to be self-contained for that data. Obviously, you don't want to have a God database. Like, obviously, you don't want to have, an Oracle RAC database that's trying to scale out massively and have your whole enterprise data model. But, if there is some distinct piece of data that needs to be managed for your business, that, I think, often indicates the appropriate size of the service in front of it.
I view things on a little bit of a different axis. I like to see all of our code being disposable code. So if something starts to get big enough that you view it as an asset that's worth preserving, then it's too big and you should target it for destruction. I think once we start viewing code as an asset, we're stepping down the dark path.
Yeah, I think echoing things that both Fred and Michael have said, one thing that I think about is whether or not you could re-implement it. So microservices should be small enough that the risks of experimentation are reasonable. So let's suppose you want to write a microservice in Julia or some other language or framework that might be perceived as risky. In the bad old days, it's like our architecture is EJBs that run on WebSphere. You can't use anything that doesn't fit this architecture. The microservices world is very different. You should be able to try experimentation, and you know what? If it doesn't work out, you should be able to re-implement that microservice without, a massive amount of time being involved.
Sort of moving on from that, Jessica talked earlier about this idea that when she heard about microservices, like, great, we can experiment with all these different languages, and that's changed over time. So what do you think about polyglots in this world? And maybe just for fun, we can start with Mike.
Just for fun, because I work for the company that backs Clojure.
Yeah, I thought that might be fun. So do you buy into the whole idea that we should be polyglots with our microservice architectures?
So I definitely view I view it as a benefit that microservices allow you to be polyglot. I don't hold it as a goal to be polyglot, but allowing diversity in the tech stacks and reducing the cost of changing a decision in each of those implementation points is really valuable. I've been at a lot of companies where, I'll give you a concrete example. I was working with a company that had their own implementation of JDO that dated back from like the first .com crash. The Java, you don't want to know, really. But this thing had been a good idea at one point in time, and now it was the foundation for their entire business. They had thousands of objects being mapped through this thing. It was their own implementation. It had diverged from the beta of the standard. There were a lot of ways in which they wanted to get off of it, but couldn't because absolutely everything used it. So the idea that you enable polyglot languages and frameworks and tech stacks is great, because then you can do piecewise change and let people experiment with the different tech stacks and say, yes, this is a good one. We should talk about it amongst ourselves and maybe spread it further. But it doesn't mean everyone then builds into that. It means, you still have the ability to change point-wise.
Fred, I know you had a lot of this stuff going on.
Yeah, I feel that just Polyglot's an aspect of environment I like to create, which is just an aspect of innovation, which you want to turn your programmers loose without constraints. And so the fewer rules you have to put in place, the better off you are. In most cases, they tend to, choose a couple of different languages to work in, maybe 2 at most. So they settle on it, but not having to tell them which one to use gives them some ability to innovate in that space. And lots of other things like that are key to innovation. It's just get rid of the rules, turn them loose with the problems.
Jessica next.
Thanks. I think what Michael said about the decoupling that is necessarily happens when you support Polyglot is really important. And so I like not using all the same language just because it forces you to not enmesh in this giant framework that is dependent on that. However, I'm not really impressed with the you should use the right tool for the job bit. I think we've emphasized that you should pick the language that perfectly fits the problem. That can get really painful. Switching from one language to another, heaven forbid you have 40 or 50 microservices on your team and you're going from language to language all day. I do that at work. I work in too many languages already and it's painful. So when you're picking the right tool for the job, that job is not just the business problem you're solving. It's the ecosystem you're working in. It's the deployment tools you have. It's the languages that you and your team are familiar with. You are part of the system that is the problem you're solving. So what you happen to know already, that matters.
I think it also comes down to what are the operational and contract requirements of the individual services. So for example, I certainly wouldn't advocate write all services in Java or Clojure or Python or any other single standard language. I think that is a mistake, and I think that does crush innovation, as Fred has mentioned. However, I do think it is reasonable to impose certain standards that might be agreed by the overall organization. Like, if you're going to expose a RESTful interface, maybe you need to provide a Swagger description of that, or RAML or whatever your preferred lingua franca is. I do think it's quite reasonable to say you can write it in a language of your choice, but it has to behave in certain ways. Maybe it needs to provide certain health check endpoints to enable it to be managed. I don't think you can have it a completely black box where, God help you what you're going to get when you invoke it, because there's no way you can know.
Yeah, so if it's a 12-factor app, it doesn't matter what it is inside, because you can operate it and monitor it the same way. I wanted to represent another point of view that Fred and I got to hear from Chad Fowler from Wunderlist, where he talked about enforcing Polyglot through his team, specifically so they would not create reusable libraries. He wanted to make sure nobody was sharing code and making reusable libraries that would be a point of coupling across the different services. Now, that's a pretty radical perspective. I wouldn't necessarily advocate it everywhere, but it's a point of view that succeeded for them.
I do think also that there is no one-size-fits-all answer. I mean, microservices architectures are inherently linked to the organizations that develop them, and different organizations have different cultures. Not every organization wants to have the same culture. So I think it's appropriate to consider that, and an organization may come down on a continuum between point A and point B in a different but quite valid place to other organizations.
Sort of related to that extreme Chad Fowler example, Chad does like being extreme. His concern there is driven about coupling, those libraries of coupling. But how do you manage coupling, and more to the point, actually, how do you manage contract evolution? How do you avoid breaking other services, and what techniques have you seen work? Or
Of course, I advocate techniques associated with event buses and asynchronous services, and the coupling level is basically at the message format levels. But we practice very permissive structures in that structure. We learned our lessons with XML. So it just has not been really an issue relative to that. In fact, we had over 300 microservices and 0 documentation of our message formats. Didn't need it. I was a bit surprised by that, but that's actually how it turned out.
I think at the coupling between services level, there's a spectrum here. There's a trade-off. At one extreme, you have backwards compatibility. Like the Stripe external API is fully backwards compatible. Not only are we backwards compatible, but whatever version of the API you receive when you first call it, you will magically get that forever. So extreme lengths to backwards compatibility is a technical solution to a problem. On the other side, you have what we do more of internally, which is coordination, which is you're actually working with a team to say, okay, we're going to change this, we're going to be backwards compatible, and then you're going to do the release, and then we're going to drop the old one. And that's less code and more people interaction. So I think you've got a trade-off there.
I think this is an important area where there's significantly more work to do. Because I think that essentially you very often get services that are coupled by something, either it's a message format or actually a contract, and I do think that people need to be very mindful about that. I think they should be explicit, which is why I really like any form of strong documentation, whether it's Swagger or whatever it is, or in message formats. It will differ, but I do think that it's pretty important to be explicit. I think it can help developers, it can help testing, it can help automation, and it can also help you spot things that might break before they actually break.
Yeah, I'm with Rod on this one, and not just because he plugged my book earlier, but truly with him on it. We've actually been developing some tooling that would take a Swagger specification and apply a derivative of our simulation testing techniques. So we can exercise an interface and say, look, your protocol states that you allow these inputs. We gave you an activity sequence that included these inputs, and look at the way you barfed all over our shoes. By using that kind of technique and generative testing, we get a lot more bang for our buck than we would with any kind of unit or integration testing. And then also by having that specification, we can apply mechanical tools to say your new version is only expanding the contract, therefore it's backwards compatible. Or we can say, you're now requiring something you did not require before. That's a contraction in your contract, not allowed. That's a breaking change. And by doing that, we can apply rules locally at the levels of individual services that make them better citizens in the ecosystem.
Yeah, I strongly agree, because I think the reality is that complexity never goes away. We're in an essentially hopeless industry fighting a hopeless battle. No matter what we do better than we did last year or yesterday, people come up with new requirements that make life harder, right? They want stuff that's more complex, they want stuff faster. So we're always fighting entropy. And the reality is, if you get rid of the monolith, some of the entropy moves to the kind of joins and contracts or lack thereof between your microservices. And that really is very likely, in my experience, to bite you unless you're actually very mindful of it.
I'll give Fred a parting word on this one, because I know he does not agree.
Yeah, I don't agree with these guys. It's nonsense. But to some degree, my environments have been different. We've been developing applications for internal consumption within my companies. So we're not trying to publish APIs. We're not trying to make contracts with the outside world. We don't have outside users trying to use our system. We've got to figure out who to blame. Those are not issues I had to wrestle with. All I had to do was build systems for an internal client to make them happy. They were sitting with me. We have those dialogues there. I didn't need to write the documentation. So I don't subscribe to the concept of you always need a document because it makes it better or it's complicated. I don't want to spend the time doing that when it's not necessary. I got more things to do with my money. And so I want to go faster, and that will slow me down.
Changing track a bit, someone's asked a question about how do you manage the front door? When you've got, say, 100 microservices, what do you do in terms of having a facade to the outside world? Is this where you'd use an API gateway or something like that? What experiences have you guys had of solving these sorts of problems?
Yeah, eventually they all come down to something that looks like a gateway / router / throttle. So that, the discovery and location and naming is one very important aspect, but there's also the operational aspect of saying, at some point your clients are going to go berserk and try to kill your system. In fact, sometimes you even do it to yourselves. I had a client that was working with a channel intelligence type of outfit and told them to go start indexing every document they had, at which point they DDoSed themselves through their channel partner. And if you don't have some means of throttling that down, you're just dead. So there's always some kind of a boundary. Oh, and put a boundary on your out calls as well, because sometimes your suppliers malfunction too.
Have you got any technology or any advice of stuff in that space?
One thing that I heard in the question, and this is a little outside of the technology because, yeah, I mean, at some point you have load balancing that is hitting certain services, but if you have 100 microservices, I hope those aren't all talking to the outside world, because at some point you still need a level of organization above the process. So hopefully these microservices are operating in little ecosystems which themselves expose certain APIs that are more intended for calls from either the outside world or maybe from other parts of the organization. And some of these 100 microservices are just little aggregators that are like, okay, there's these 3 internal services, I'm going to put this stuff together and give it to you in a format that is legible outside this team.
I agree with Jessica's point there. I think there's stuff that we learnt in the old world of writing very large monolithic applications that can still be valuable. One is, like, if you've got a number of subsystems in a large monolithic application, you want to limit the coupling between them, right? You want each subsystem to provide a surface area that is manageable to other subsystems. And I see that as pretty much the same issue as Jessica outlined, except that obviously it's with a different set of technologies. I think, honestly, if you let your external clients at all your hundreds of microservices, I mean, you may as well give up, because bad things will happen. They will happen.
Yeah, I think the situation is kind of analogous to if you're building a large monolithic system and giving access to everybody, to every class you have with every public method available. No, there's just a few of those out to the outside world. A few gateways into the system churns on itself and spits answers back out. And I do the same thing when I build microservice systems.
Sort of related to this in a way, how should microservices talk to each other? Should they only ever use asynchronous message buses? Should they just talk via HTTP, protobuf, thrift? What's the right answer?
I think there's no right answer to this. I think it depends upon a lot of the problem, but I think it is sort of an architectural decision to be made quite early. Are you going to go sort of a synchronous, RESTful registration process, or are you going to try to decouple even further? And I think the type of problem you're trying to solve drives that answer.
I think typical systems will end up having some cases of both, but I mean, obviously, stacking up synchronous calls is not going to work. So I don't think that you can build a system of any complexity purely through synchronous operation. You can build a system of any complexity using asynchronous invocation, but in some cases that will probably end up being more complex than something that involves some synchronous usage. I mean, I think ideally we should look to technologies that actually make it relatively easy to make that choice. So for example, if I was implementing a microservice, I would want to implement as much of the functionality as possible so it could be behind different styles of invocation. So for example, I wouldn't want to, say if you're writing in any technology that has web controllers, some kind of RESTful controller, I mean, obviously you don't want to bake your business logic in there, because that's going to be a problem if you ever realize that perhaps a messaging approach was better.
Cool.
I will say that consider maybe not doing everything over HTTP and JSON. That is like the first thing, and it's the easiest thing. And part of the reason is because it's kind of like human understandable. And one of the problems with microservices is traceability, is how do you know what went where, and how do you follow the bits? And if you've got the JSON printing to the logs, like we do at every request, then that helps with debugging, and it helps with human understanding. It does not help with speed. So at the point where that gets too slow, consider 0MQ or something faster. Not a protocol person. But then consider how you're going to implement traceability and how are you going to add legibility to this system, especially as it grows and gets more complicated.
So how should microservices talk to each other? Why, through circuit breakers, of course.
Well, there is a resiliency conversation to be had here, isn't there, Mike? I mean, some of the protocols we pick don't always lend themselves to...
Yeah, I'm being a little tongue-in-cheek, of course, but in my workshops and in my sessions, I definitely point out that most of the operational problems we incur come from synchronous request-reply type of protocols. So it's not enough just to introduce an event bus. If you're going to do event-style communication, don't send an event and then demand to get back exactly one event. Sort of announce what you have to announce and listen for what others have to announce and then synthesize your result. But don't just reinvent RPC over a message bus.
Yeah, I actually think in terms of, I agree with Jessica's point that obviously JSON serialization is potentially very inefficient, but I think that, as we all know, premature optimization is the root of all evil. Very often I think it's actually a pretty good starting point. It's very traceable, as she said. I'm always wary of saying, well, this won't be fast enough, so let's make it more opaque. No, let's see. Let's see what happens, because it may well be that the opacity is more dangerous than the latency.
Somewhat related to this area is a question here around caching. So can you comment on caching between microservices? Have you used reverse proxy layers, or do you commonly use caching inside the service with things like Redis? Maybe Fred?
We're definitely fans of caching, primarily because we can work with eventual consistency in the problems we tend to solve. So the fact that I'm a little bit out of date with everybody else is kind of okay in the domains I tend to work in. And so I'm perfectly okay with caching, but it's something I don't tend to put in there unless performance says it's necessary and provides some value to me. I'm very lazy about what code I decide to write because I'd rather write new functionality than make the old work a little better.
Yeah, I mean, coming back to my point about premature optimization and opacity, if you really want to make a system harder to understand, just sprinkle some magic caching pixie dust, and you'll make it very hard to figure out what's going on. Obviously, having said that, caching is very, very important to making many applications work. And of course, we also have the option frequently of caching on the client, which can actually be really good because it can avoid sending a message or making a network call, and often it is the client that really understands its need for updated information. So often the client understands a tolerance for staleness much more than something that's serving content.
Took the words right out of my mouth.
We've sort of outlined some of the challenges. There's lots of questions to be answered here about how do services talk, how do you handle performance, and that's a lot to take in. As a question here was, how do you know if microservices are right for you? I mean, is there any organization you wouldn't suggest microservices for?
I've definitely walked away from clients that said they want to do microservices. And generally, I'm looking for the enablers in place to be successful. I'm looking for an organization that if maybe they don't have one-click deployment, but darn close to one-click. And if they're not there, if they've got a 2-week deployment process, it's like, go fix that, then call me. I'll also push pretty hard to make sure that they have a problem that needs to be solved with microservices, that they have a real problem that just is worth sort of retraining the programmers, refocusing other organization resources. And if you haven't got support almost from the top level, the CIO level, that says, I'm going to make this sort of transition, because there is social implications to how we're doing things. If you're not ready for that, again, walk away and come back when you're ready.
Mike?
Yeah, I definitely agree with all of that. Moving to this style requires a very high degree of trust in the individual developers and their ability to be responsible for the things that they create. And just most organizations are antithetical to that kind of trust, especially the bigger and the older ones.
I think it also depends on whether or not the organization has a problem. I mean, there exist organizations who are successfully deploying monolithic applications. I think one of the dangers that can cause any technology to get a bad name is when people start to adopt it because they feel they should adopt it, rather than because it really provides value for them in particular. So, I think that if an organization is perfectly happy with their monolithic style, maybe they should stay there. I suspect that most organizations are not, but I think we should be very careful of just running after shiny objects.
Yeah, to agree with some of what Rod said, my first reaction is, do you have to? I mean, we're talking here about, well, how do they talk to each other? Do we need caching? Oh, we definitely need circuit breakers. There's a lot of decisions. And then there's the documentation, and then there's the tracking, who depends on what, and then there's the traceability. These are a lot of problems that you just don't have when something runs in a single process. Do you need to take that on? And I would say you probably do at the point where the coordination among people with deploying in the monolith and they're getting in each other's way. But this is not an all or nothing either. You can say, this team is particularly on a different deployment schedule than this team, and they're getting in each other's way. We need to draw a line here and separate those pieces.
We need more disagreement on this panel, so I'm going to disagree, partially, because I think, and I'm going to give another plug for Michael's book, because Michael's book actually gives some great examples of where you can't ignore things like circuit breakers in monolithic applications. So it may well be that some of the complexity that we talk about in microservices, it may well be that some of that complexity is still going to bite you if you don't address it even in a monolithic world. So it's not like all these problems are new.
One more add-on. We were talking just before the panel about how there's a very strong correspondence between a certain style of OO development that we mostly saw in the Smalltalk world, and the way that microservices ought to work. The notion of sending messages, describing things in terms of the behavior that they offer, not the data that they contain, having things that are fairly large-grained and fairly responsible for their own activities. All of those traits can be true in an OO world, i.e. a monolith, and they can be true in a microservices world. So if you're going down the monolith first, then microservices path, just make sure that you do practice, good, sound OO design. Don't automatically create a layered structure where every domain concept appears at every layer except suffixed with table and DTO and domain and what have you all the way up through. Definitely think about the horizontal isolation between different parts of your monolith. And look for those subsystem boundaries where you can put a facade object that acts as an internal API in front of a bunch of objects. And you'll find that that's a very natural transition then to microservices later, almost isomorphic.
Fred?
My journey to microservices actually started with building monolithic object apps and seeing those. And one of the phenomena I saw was after a few years, the glorious structure we put together gets completely crippled and destroyed. To some degree, my journey in microservices is trying to build a defense that makes it harder for the casual programmer who goes into your monolith and destroys it to do the same thing in another system. If you go into a microservice and destroy that microservice, okay, I got 100 lines of code to rewrite. I can do that. But you're not destroying 45 other microservices as you used to be able to do in a monolith.
One interesting benefit of microservices is I think that it can prevent people trying to be too clever. So one of the things you can do, if you've got a really large monolithic code base and you're writing in a language with an advanced type system, for example, you can do some amazing stuff. You can, say, for example, if you've got the Scala type system, you can create things of wonder. And the problem is that they can actually become rather difficult to work on. Whereas I think once you break the functionality into these relatively small things and they talk to get to each other in relatively dumb ways, you are actually prevented from raising, magnificent intellectual edifices that may haunt generations of programmers.
Jessica, did you want to?
I wanted to add to Michael's point that yes, practice isolated object-oriented design, and that takes care and exactly not having anyone come in and mess it up in the name of removing duplication that is really just code that happens to look the same. But be careful on the database side, because if code from this object is reaching through to the database for something that was actually maintained over here, you are screwed, because changing code is hard, but migrating data is immensely harder.
I think I'd also point out that Fred name-dropped Parnas earlier today. He's the person that kind of invented modules, and many programmers have never even read his papers. So I think a lot of people who create bad monoliths should maybe just learn about what a module is.
I just like quickly to echo Jessica's point about not exposing the database. If you heard my presentation today, I said lots of nice things about Spring. I think they're doing some really cool stuff. But one thing that they've done recently that I don't think is cool is auto-magically exposing your data store using REST. I think that's a truly horrible idea. Obviously, it's not unique to Spring. Many technologies have made that very easy to do. It is really, really dangerous. If you want to do that, view yourself as writing something that is going to be throwaway, because your chance of evolving that is nil, basically.
We did get a question on that, actually, was, do you have to hide your data? Fred, your talk was all about that earlier today, really, in many ways.
I think it gives you the robustness to hide the data. I think when services give their data away, they're just begging somebody else to do the calculations for them, and now you got 45 places to change. I mean, the code base I worked in India, I tried to write a unit test. I wanted to allocate an object and get, make sure it's not nil. That's all I was trying to do. It took me 7 hours to write that test, because it just pulled in this code and this code and this code and this code because those boundaries were broken. So yeah, I'm huge on keeping those boundaries strict.
Sometimes you really need the data in two places, maybe for performance reasons. Okay, one service is in charge of that data, and you could replicate it from one place to the other if you need that for performance reasons or something. That's still code that's under your control, and if the structure of the data needs to change, there's code that you can change to accommodate that.
So Fred was talking about the entity services trap earlier, and I was actually hoping he would rant even more in his talk. But if you didn't see the talk, you should watch the video. One of the things that I always think about with microservice designs is, for any given type of request at the edge, what are the set of services that get activated during processing that request? So if you think about your tracing framework, you say, request comes in here and it lights up this service and these nodes and these services and so on. You can draw an activation graph for every kind of request. And what I find when people implement entity services is all of their activation graphs end up with this bottom layer entirely lit up for all the entity services. What this means is all of their features have common mode dependencies on those entity services, and if there's a problem with one of them, or if there's a downtime or an outage or a release happening, all features are damaged simultaneously. And so I always like to draw these activation graphs and sort of intersect them and see, is the intersection of all of them empty? That's great, because then you can have some of your stuff down and other parts of your enterprise don't even care. Is the intersection all of your entity services? Then you might as well not bother.
Might as well be an Oracle.
Might as well, yeah.
So changing track a little bit, what about user interfaces? I think we've been talking about services talking to other services a lot here. What about how do human beings talk to all those services?
Yeah, so I've got one counterexample and one pro example that I'd like to offer. I talked to a company that had done a big microservices migration. They were a financial services company. They work in many different geographies. And the requirements for creating an account in each geography were a little bit different. And so they had created an account service for each geography. And the UI needed to know what to feed each geography. So the UI was built to know the requirements of each service in each geography. I think pretty clearly this is an example of doing it wrong, right? They got through this big migration, they found they couldn't change anything any faster than before. On the flip side, we're seeing more interest in these demand-driven architectures. Falcor is one, Ohm.next is another good one, where the client side actually gets to tell some entity, hey, these are all the things I need to know about, give them to me. And that makes a good query interface. And it's up to the thing on the other end to go and fetch the entities from wherever it needs to. Be that one service, a proxy in front of many, or whatever, it doesn't matter. And then the change side of things is not just like a put or a post and a RESTful interface, but we're actually seeing the change being encapsulated as an action and posted as a transaction, as a unit of work. And that's a pattern that we're finding to be very effective, where you query based on a demand-driven style, and you apply a transaction as one unit.
Yeah, I would like to echo that. I think GraphQL and Falcor are very interesting.
Cool. Now, I guess a question, another question that's come in here is arguments about scalability seems to ignore other techniques like plug-in architectures. They didn't say OSGI, but that's often a conversation I've had with people is, okay, why have separate processes? Why not just have a runtime that I drop different components onto? I mean, it's kind of how Erlang works. It's what OSGI tries to do. So what are the pros and cons of those approaches versus microservices?
I actually think that there should not necessarily be a one-to-one mapping between a microservice and a container. I think that is a very, very good deployment choice in probably the majority of situations. But I think that potentially an infrastructure should be capable of providing choice there. So, but nevertheless, I think that given that the cost of containerization is now so low, you wouldn't necessarily, choose to scale out your system entirely within process. I mean, when you had to rack up a new server, that was a different case.
Cool.
So in my view, it's all about proper isolation. So when we used to deploy things into Java containers, the idea was that the Java server could properly isolate the applications from each other. Never worked. We always had class path interference.
JBoss.
Operating systems are supposed to completely isolate applications from each other. Yeah, except that they depend on things like network configuration and TCP settings. So we're still trying to find the right way to separate these concerns of packaging the application, delivering the application, and isolating them from each other. Right now, the excitement is containers and unikernels, but that may not be the final story.
Yeah, as I said, I think there should be the potential to have a mapping where you're not automatically just containerizing. So for example, in particular environments, it may be, in some test environments, you don't care that much about isolation, you just care about reducing footprint.
This came up in the keynote this morning. He talked about the VS Code, and instead of a plugin architecture, there were like extension hosts, so that each of those hosts could be a separate process and could run in whatever language, so you could write your C# stuff in C#. And so there's the Polyglot really helping, and also that isolation of you're not going to run my process out of memory.
Probably got time for one last question. What about testing? Because testing seems difficult anyway. And with microservices, it just seems more complicated. So any tips from the panel around how to test your shiny new microservice architecture?
Well, I already alluded to our generative testing for individual services. And I'll say the reason that we're moving in that direction is because we've been talking about and promoting and implementing simulation testing for quite a while. And simulation testing is an end-to-end approach that can exercise all of your services end-to-end. And actually, one of the things we found is our clients are all moving away from centralized QA teams, and there's actually nobody responsible for end-to-end testing and end-to-end QA anymore. Interestingly, one of the ones that sort of told us that story about 6 months ago has come back and said, well, we're kind of thinking about a central QA team to check the end-to-end behavior. So I think it's a pendulum that keeps moving. Personally, I prefer to explore a lot of the state space as much as possible for my automated testing. But then I also do a style of contract testing where if I have things I depend on from another service, I write tests that exercise the things I need specifically from there, not the comprehensive API, just the stuff I need. Then if that breaks, I know that they've done something wrong and I can go yell at them.
Fred?
So obviously I'm on the other end of the spectrum from this and the other end of the panel from that. Yeah, in environments I've tended to work in, again, we're developing for internal users, we don't do unit testing, we don't do integration testing, we don't do staging testing. In fact, we basically deploy from notebook to production. What we have done is, because our production environments have been heavily instrumented themselves, and we can see basically all the key performance indicators for our business are basically available to us as well, we deploy and see what happens to our real metrics. Are we getting more logins? Are we getting more sales? Are we getting longer page retention times? Whatever the metric is, we're measuring that. And we're deploying to live environments and see what happens. If we deploy something that's not reacting very well, we take it back off. Now, that said, we are working in environments where we do get that fast customer feedback. And that has eliminated the need for the integration testing.
Jessica?
So I don't think this is a solved problem. I know what I like to do, which is when I'm testing my service, I want to be able to test it without accessing the real dependency, whatever it is, and it could be the database as well as another service. So I wind up making a fake that lets me unit test and generative test and run a whole ton of tests on mine. What I wish is if that other service would give me a client library that included a fake mode, and then all I have to do is test the fake once in a while against the real service. Like if I had a fake GitHub, then I could just test that against fake GitHub to make sure it's consistent, and meanwhile run all my tests super fast. It's what I wind up creating in the small anyway, and it's a lot of work. I have more test code than real code if I'm doing it well.
This is one of the reasons that I'm a fan, at least for the synchronous case in Java, of using things like Netflix Feign or Square Retrofit, because they make it really, really easy to test how you're using that service with mocks or fakes or whatever. But I mean, I'm going to come back to the point that I think it's pretty important that something has a contract. If I want to test something, I want to know what it's supposed to do. And I agree with Michael in terms of the value of that approach.
And I think leaving on a disagreement is a good place to end a panel. So I want to say thank you to our panel members. And thank you very much for all the questions. I'm sorry we didn't get a chance to get to all of them, but they're all around tomorrow as well. So feel free to corner them and pepper them full of questions later on.
At the party.
At the party, there's going to be beer. So thank you very much.